We will be taking the derivative of the function f of x equals x squared plus 4x minus 5. So we know the definition of a derivative as the limit. So a couple things with notation. Remember, derivative, we can list it as f prime of x, or we could say y prime of x. And then sometimes you'll see dy over dx. And those are all equal to each other. And they're also equal to dx of our function f of x. Okay, so that actual d over dx, ddx, that is kind of an operator. It's telling us to take the derivative of the function f of x. It doesn't actually mean derivative. So in that notation, it must be with the function itself. Okay, so I'll just stick with f prime of x. So our derivative f prime of x equals the limit as h approaches 0 of the difference quotient. So f of x plus h minus f of x all over h. And we talked about this in the last lesson. So that comes from finding the slope of the tangent line at any given point x. Okay. So first thing we need to do is, what I like to do, I like to break it down into parts. So I'm going to my first part, I'm going to find f of x plus h. I like to do this separately before I actually put it into the limit, because sometimes it can get a little messy. Especially in this example here, we've got 3 terms in this quadratic function. So let's do this component first. So our function is up here, x squared plus 4x plus 5. So essentially every time that we have an x, we are going to substitute x plus h in. So I have x plus h squared plus 4 times x plus h minus 5. And I'm going to expand that. So x plus h squared, I kind of know my quick trick. It's x squared plus twice the product of those values, so 2xh plus h squared plus 4x plus 4h minus 5. Okay, I can't cancel anything out there, so that's good for me. So the next thing I'm going to do is I'm going to put it all into my limit. So now I will find the limit, which is essentially finding the derivative. Okay, so limit as h approaches 0. Now, instead of my f of x plus h, I'm going to put this whole big long polynomial into that. So I'm just copying directly from there, x squared plus 2xh plus h squared plus 4x plus 4h minus 5. I have to subtract f of x. So if I'm subtracting that entire function, the easiest thing, I can just flip all the signs. So it's going to be minus x squared minus 4x, and then that minus 5 is going to become plus 5. And this is all over h. All right, now we can do some canceling out. I see some terms here that essentially one is positive and one is negative. So x squared and negative x squared cancel out. What else do I have here? 5 cancels with the negative 5. Anything else? Yes, my negative 4x and positive 4x. Okay, all right. I think that's it. All right, so I will rewrite this a little. So remember, every time you rewrite your limit, you need to repeat that limit as h approaches 0. So now I see in my numerator, I do have an h in every one of those terms, so I'm going to factor that out. So h times 2x plus h plus 4 all over h. Now that's going to enable me to cancel out those h's. They divide out, leaving me with the limit as h approaches 0, 2x plus h plus 4. All right, at this point, I can do my direct substitution of that 0. So for h, this is when I'm going to substitute it in. So I have 2x plus 0 plus 4. So the limit is just 2x plus 4. I'm going to rewrite my f prime of x and box it in.